DocTest is a testing framework. It serves well to document functions, but when there are a lot of tests, it can obscure the code inside a function. There are other testing frameworks that don't suffer from this problem. One of them is UnitTest, which comes with Python. In order to use UnitTest, you need to learn a little bit more about some Python language features, and in particular, how to create your own type. You've used lots of types: strings, functions, modules, dictionaries, lists, booleans, and more. All of these were written by programmers working for the Python Software Foundation, the organization that manages the Python programming language. We'll start by re-examining some of these existing types, and then we'll see how to create our own. Module math has a lot of functions. One of them is math.ceil, which returns the ceiling of a number. That's the smallest integer that is greater than or equal to the argument. We call it like this. Module math also has data, in particular variables e and pi. Importing math creates a variable called math that refers to a namespace. That's a chunk of memory with names like a, cosine, ceiling, and so on listed inside, each of which point to a function object, as well as e and pi, which refer to floating point numbers. As you know, types such as int and str contain a special kind of function called a method. Here is the output of calling function help on type str. Str is a class, and a class is Python's way of defining a type. An example of a method in class str is count. String method count counts how many times one string occurs in another. Because str is a built-in type, we already have variable str. It refers to a class rather than a module, but it looks much the same, with names like center and count listed inside, each of which refer to method objects. Much like we write math.ceil with argument 3.2 in order to call the ceiling function in module math, we write str.count and pass in a string and the substring to search or count in that first string. Again, as you've seen, because methods are special in that they expect an instance of the class as the first argument, we can, in the object-oriented way, call syzygy.count y. This is the standard way to call methods. Class string has a lot of helpful methods, but there are some that are missing. We're going to write our own class that customizes class string. Our class will have all the string methods, but we'll also add one that checks whether a string starts and ends with the same letter. Here's how we start our class. The first line tells Python that we are defining a new class called wordplaystr, and that it's based on class str. We say that wordplaystr is a subclass of str. It inherits all of the features of str. As we said, our class is a string class that has a few additional features. Let's make a new one. We can find out its length, and we can call string methods. We can even compare it to a regular string. So far, it behaves identically to a string. Its type, however, is not str. It's wordplaystr. Let's create a file where we can write our new class definition, including the methods that we're going to add. Here's the class definition as we had typed it in the shell. We can add methods to our class. Let's add one that returns true if a word starts and ends with the same letter, and returns false otherwise. Following the design recipe, the first step is to come up with examples. We'll create a wordplaystr where the first and last letters are the same. Then, when we call our function that we're writing, maybe we'll try same start and end. We hope that it returns true. If we create a wordplaystr where the first and last letters are not the same, then when we call our method, we expect false as the result. The name same start and end for our method seems fine, so let's fill in the header. There is one parameter, which we call self. That's the wordplay stir that owns this method. The type is wordplay stir, and this method returns a Boolean. Description is return whether self starts and ends with the same letter. Because class wordplay stir inherits from class stir, we have access to all of the string functionality. That means that we can use indexing. We can look at index 0 and compare to the letter that is at index -1, and same start and end should produce true if those two are the same, and it should produce false otherwise. This won't work on an empty string, so we'll add a precondition to forbid that. Let's add an if name equals main section at the bottom to try out our doc test. We run it, our tests pass. It's important to note that we haven't changed class string. It doesn't know about these new methods. Only our subclass, wordplay stir, has the ability to check to see if it has the same start and end character. We'll see a deeper explanation of classes later in this course, but you are now ready to tackle Python's unit test module.